All right, this is lesson 9.7, which is solving quadratic problems involving objects that are dropped under the force of gravity. So remember that the gravity is the force that the earth is pulling you down. Okay, so dropping objects and the gravity's pull on that object, no matter the weight of an object, the earth's gravity pulls the object down to the ground at the same rate. Let me expand on this. Let's say we have this really tall, kind of larger person, and then let's say we have a little kid. Right, there are these two people. These two people are being pulled down to the ground at the same exact rate. Like, it's not like the little person is floating off in the air, right? They're both on the ground and they're both there. That's gravity's pull. Now, the longer that an object is falling, the faster it falls. Every second an object falls, it falls 16 feet per second faster. So let's imagine for a second that we put these two people now on top of a building. And they both fell at the same time. They're going to continue to fall at the same exact rate, and the longer that they fall, the faster and faster that they fall. They're actually going to hit the ground at the same exact time. So the way that we figure out how far something has traveled is we use this formula, d equals 16t, where d represents the distance traveled, in feet. And then t represents the time elapsed in seconds. So in order to find out how far something has traveled, we need to know how long it's been traveling for and substitute it into this formula. So let's go ahead and start there with this example. Jasmine was observing her house from a hot air balloon when she accidentally dropped her telescope. So let me draw a picture over here. There is a hot air balloon. Let me do my best. Maybe it looks something like that. Either way, there's this person inside of it, right? So Jasmine's in a hot air balloon. She's looking at her house in a telescope. And she drops her telescope. Her telescope's going to go straight down. Okay? The question is, how far has the telescope fallen after 1 second? So we're going to use the formula d equals 16t squared, right, to find out how far it's fallen, d, given a time. So how far is referring to d, and 1 second means t equals 1. So we're going to solve this at t equals 1. So we're going to substitute 16 times 1, which is 16. So d equals 16. What this means is after 1 second, the telescope, it has traveled 16 feet. So again, it's fallen, it's traveled 16 feet in 1 second. Okay, part B, how far is the telescope fallen after 2 seconds? So take the same formula, and we're going to substitute t equals 2. 2 squared is 4. 16 times 4 is 64. So after 2 seconds, it travels 64 feet. So it went 16. Now it went a total of 64. Okay, last one. How far is the telescope fallen after 10 seconds? Same thing, except now we're substituting in t equals 10. So 16 times 10 squared. 10 squared is 100. And 16 times 100 is 1,600. So after 10 seconds, it travels 1,600 feet. Okay? So that's about distance. Now let's talk about the altitude of an object. So altitude, quick definition, the altitude is how high above sea level an object is. So if something is 200 feet above sea level, then if this is the ocean, then it's 200 feet up. That would be an altitude. So the altitude of a falling object can be calculated using the formula which subtracts the distance an object has fallen, which we just found as 16t squared, from the initial height of an object, which is h. So the altitude, here's the altitude, and this is in feet, equals h, which is the initial height, also in feet, minus 16t squared, which we just found out was the distance traveled. So we're going to take how high something was and we're going to subtract how far it's fallen to find out what the actual altitude is. Let's go ahead and do this example. Lupe dropped a rock off a cliff 1,600 feet above the ocean. Complete the table below. So 1,600 feet, this is the initial height. So we're going to substitute that in for h. So the equation is a equals the initial height, 1,600, minus the distance traveled, 16t squared. And we're going to go ahead and substitute in these different times. So we want to know what's the altitude after 0 seconds. What's the altitude after 5 seconds? What's the altitude after 12 seconds? So let's do it after 0 seconds. T equals 0. So A equals 1,600 minus 16t squared at time of 0. So A equals 1,600 minus 16 times 0 squared. 0 squared is 0. 16 times 0 is 0. So the altitude is 1,600. So after 1 second, no, 0 seconds, sorry, the rock is 1,600 feet. Oh, sorry, is at an altitude of 1,600 feet. Sorry. Which makes sense because if there has been no seconds, then it's still at its initial height. It actually hasn't moved. So I'm going to add on here. It hasn't moved. All right, let's see after 5 seconds. T equals 5. Altitude equals 1,600 minus 16 times 5 squared. So that's 1,600 minus 16 times 25, which is 1,600 minus 16 times 25. I'm going to do some scratch work. And that's 400. So again, the altitude will be the initial height minus the distance traveled. So it's traveled 400 feet, giving us 1,200. So after 5 seconds, the altitude is 1,200 feet. So it started at 1,600. It fell 400, which means it's at a new altitude of 1,200. Cool. All right, number 12, or sorry, T equals 12. Area equals 1,600 minus 16 times 12 squared. So that's 1600 minus 16 times 144. So I'm going to go to the side, do 1600. No, 144 times 16. 24, 24, 25, 26, 6, 7, 8, 4, 4, 1. Oh wait, sorry, 8, 9, 10, 11, 12, 13, sorry. 2,304. So it's traveled 2,304. The initial height was 1,600. You subtract the 2. Six, 4, 5, 6, 7. Negative 704. So after 12 seconds, it's at a height of negative 704 feet. It's at an altitude of negative 704 feet. That doesn't really make sense, because if it's at an altitude of 1,600, the rock can only fall 1,600 feet. So after it hit the ground, it's like it's going underground, and you can't really do that. Once something lands, say like my pen, it's going to land and stay on the ground. So really what this means is that since it's been 12 seconds, the object has already hit the ground. The rock has already hit the ground after 12 seconds. So it's already hit the ground. The next question is going to be, when did it hit the ground? So, looking at number 3 on the next page, here is the same exact question, except there's a new question attached to it. Lupe dropped a rock off a cliff 1,600 feet above the ocean. When will the rock splash into the ocean? There's 2 inferences that we have to make here. The first one we've already done together. If it's 1,600 feet above sea level, that is its initial height. So one inference that we're going to make is that the initial height is 1,600 feet. The second inference that we need to make, when will the rock splash into the ocean? If something is splashing into the ocean, okay, so here's the ocean, here's a rock. When it hits the ocean, you're at an altitude of 0. You have hit the ground. So the inference that we make here is that the altitude is 0. So we take our equation, initial height minus distance traveled. We're going to substitute 1,600 in for h and 0 in for a. Now this is a quadratic, and we can solve for t. To solve for t,